This video is about applications of exponential functions, and we're doing a rather challenging problem about half-life. The radioactive element of carbon-14 has a half-life of 5,750 years. The percentage of carbon-14 in the remains of organic matter can be used to determine the age of that material. Recently, near Patuxent River in Maryland, archaeologists discovered that charcoal had lost 8.1% of its carbon-14. So what that tells us right there is that there's 91.9% of the carbon-14 remaining. It's only lost a small portion. The age of this charcoal was evidence that this is the oldest dwelling ever discovered in Maryland. And what we're trying to find is what the age of this charcoal is. To do this problem, we're going to be using our equation we use for all of these exponential growth and decay questions. P of t equals P naught e to the kt power. Our plan is to first figure out what the k value is. We're given the half-life. So that means we're given some information about the original value and the new value, so P naught and P, given the time. We don't know at this point what the K value is. So we're going to first find the K value. After that, we're going to rewrite this exponential, and we're going to use that new equation to answer the question. So find K. Using this equation and the information we're given, we're told that the half-life is 5,750 years. At this stage in the problem, 8.1% is not coming into play. So if half of the amount is remaining of an original value of P naught, that means our equation looks like 1/2 P naught equals P naught times e to the k, and then our time is 5,750. At this point, if we divide both sides by P naught, these P naughts will just neatly cancel out. We don't need to know that actual value. This gives us 1/2, or 0.5, equals e to the 5,750k. We've isolated our exponential. At this point, we want to take the logarithm of both sides. It is convenient to take the natural log. We use our property of logs to rewrite this exponent as a multiplication in front of the problem. I'm going to advance to the next slide, give myself more room. So we had the natural log of 0.5 equals 5,750 times t times the natural log of e. So again, at our previous slide, this 5750k was up in the exponent. Oops. And so now we've brought that exponent down and written it as multiplication. So natural log of 0.5 is just going to be a number. And this is equal to 5,750k times 1, because the natural log of e is just 1. At this point, to solve for k, we just divide both sides by 5,750. And this is something we can plug into our calculator. And we should get a k value that probably looks like this. Negative 1.20547 e negative 4. That e negative 4 means times 10 to the negative 4 power. If you're not comfortable with scientific notation, I recommend rewriting this as k equals negative 0.000120547. That's our k value. Rewriting the equation, what we have is we have p as a function of time equals our original p-value times e to the negative 0.00012. I'm actually going to round it from there. It's dangerous to round this too soon, but I think that's an appropriate rounding spot. Times the time. Now that we found our k value, going back to our previous slide with our game plan, our next step is to rewrite the exponential equation with the k value. That's what we just did right here. There's our new exponential equation. Our third step is to use this new equation to answer the question. So what the question was is, given that 8.1% of its carbon-14 is lost, what is the age of the charcoal? So what we want to do is we want to find time. If 8.1% of the carbon-14 is lost, that means 91.9% remains. So using this equation right here, we can plug in this information. And again, what we're trying to do is we're trying to solve for time. So 91.9% of the original value of carbon-14 remains. We can rewrite this as 0.919 p naught. So we have 0.919 p naught equals p naught times e to the negative 0.00012 t. Divide both sides by p naught to isolate your exponential. 0.919 equals e to the negative 0.00012 t. Going to copy that down again. 0.919 equals e to the negative 0.00012 t. Now, to get anything out of the exponent, what we have to do is we have to take logarithm of both sides. Again, since this problem has to do with e, it's going to be most convenient to take the natural log of both sides. The natural log of 0.919 equals the natural log of e to the negative 0.00012 t power. We're going to use the principle about logs that we can rewrite an exponent as a multiplication. So this becomes the natural log of 0.919 equals negative 0.00012 t times the natural log of e. The natural log of e, that's just a number, and what number that is it's the number 1. So at this point, to solve for t, I'm just going to divide both sides by negative 0.00012. Dividing this, we end up with approximately 700 equals t. It actually works out to be 700.7155, but with a rounding error. That tells us that the age of this charcoal is about 700 years old. Thank you.